So this is question 5 of the C2 2015 paper, looking at sequences. Now, for the first part of the question, we see that the sum of the first two terms is 34, and the sum to infinity is 162. No more information is given than that, and you're trying to work out the common ratio and the first term. So, first of all, when you've got a question like this, I would say to just put all the information, write down all the information that you know. So if you know that the first term, the sum of the first two terms, so the first term plus the second term, will add up to become 34. That means then that actually putting it in terms of geometric sequences, it's going to be a plus ar is equal to 34. And we also know the sum to infinity is 162. And in your formula booklets, you'll see that sum to infinity for a geometric sequence is given as a over 1 minus r, which we're told is 162. So actually, if you take a look at what we have with this formula and this formula here, we have a simultaneous equation. So looking at this equation, let's call it equation 1. Let's rearrange it. So we're going to end up with a being the subject. So let me just rewrite this equation here. So a plus ar equals 34. Let's factorize out the a. So we're going to end up with a bracket 1 plus r equals 34. And then so finally a equals 34 over 1 plus r. And we're going to substitute that into this equation here. So that means that instead of that a at the top, we're going to have 34 divided by 1 plus r, which is all being divided by 1 minus r, equaling 162. Which then, of course, means that I have to do some sort of, rearranging, so we end up with r being the subject here. So when you're dividing by, when you have a fraction as a numerator divided by just a single term at the bottom, or a single expression at the bottom, sorry, you can just assume the denominator and the denominators, they multiply. So actually you're going to end up with 34 over 1 plus r, 1 minus r, is equal to 162, which then we can rewrite that as 34 over 1 minus r squared, which is equal to 162. Notice that I've expanded here. Now I'm going to rearrange this equation so to get 1 minus r squared onto the top, which means I'm going to be timesing by 1 minus r squared and dividing by 162. So I'm going to end up with 1 minus r squared is equal to 34 over 162, and just to make life easier, I'm going to make that 17 over 81. After that, I'm going to then just rearrange it, so I'm going to end up as r as a subject. I'm just going to move it down to the next page. So r as a subject, so we're going to get r squared as a subject. It's going to end up being 17 over 81. I'm going to end up with 1 minus 17 over 81, which means that r squared is going to be 64 over 81, therefore meaning that r, in this case, is going to be 8 over 9. Remember that every single term of this geometric sequence is positive, so even though you would have ended up with an answer of plus or minus 8 over 9, remember that you're going to take the positive from this. So that there is how you'd end up with the first 4 marks of the question. Now we know that r is equal to 8 over 9. The second part of this question, we're trying to find the first term now. And we know the first term is a. A, we've already worked it out previously, a can be written as 34 over 1 plus r. We know what r is already, we know that r is 8 over 9, so let's just substitute that straight into here. Let's choose a different colour, I'll choose purple for this bit. So now a would equal 34 over 1 plus 8 over 9, and you can just type that straight into your calculator, and you should end up with the answer of A equals 18. So that will give you the first 6 marks of this question. So the next part of this question says a different geometric sequence has a first term of 42 and a common ratio of 6/7. So we know that A would equal 42, and we know that R is equal to 6/7. And we says find the smallest number or smallest value for n for which the sum of the first n series exceeds 290. So essentially what we're saying is that the sum, or really we're looking at S of n, at this point just going to say it equals 290. So we're trying to find a point where it actually equals 290 for n. Now again, looking at your formula books, you're going to have the S of n, or the sum of n numbers, is the same as A bracket 1 minus r to the power of n all over 1 minus r is the formula that we're going to be using. So just go ahead and substitute in everything that you know. So we know that 290 would be equal to A, which is 42, open bracket 1 minus 6/7 to the power of n, all over 1 minus 6/7. Or, to put it a nicer way, we could just say that 290 is equal to 42 over 1 minus 6/7 to the power of n divided by 1/7. So, thinking about what we're going to do here, I'm just going to tidy up this bit of it, and we're going to end up then with 290 is equal to 294 bracket 1 minus 6/7. I'm actually going to put this in brackets this time, n, like that, because actually dividing by a seventh is the same as timesing by 7, so 42 times by 7 is 294. Now, a really common mistake here is to take that 42 and multiply out the brackets. So you're gonna, if you multiply out the brackets here, I'm gonna put it in red because it's wrong. People end up with 42 over, and then do 42 times by 6/7. So they'll actually end up doing 42 times by 6/7 to the power of n, therefore completely changing what you have. So make sure you do not do this in an exam or any mocks or any questions or anything else that you're doing. It's wrong, don't do it. Anyway, moving back onto what I was on about, we go back to the purple, and now I'm just going to rearrange everything that I can. So I'm going to divide by 294, so you get 294, so it's 290 divided by 294 is equal to 1 minus 6/7, again I'm just going to put these in brackets for now, to the power of n, which when you rearrange everything you'll end up with, let's make 6/7 n the subject, will end up with then that being 4 over 294. So we're trying to find the value for n. Sorry, let me just remove this information because it's not useful. So from here we're trying to find the value for n. We know, well, n is the power, so now we're going to have to take logs from both sides. Now I'm going to take logs with the base 6/7. So we actually end up with here being n equals log to the base 6/7 of 4 over 294. And typing that into your calculator, you'll end up with a solution of n equals 27.877, etc. Now, so what we're saying is that when n is 27.877, etc., then the sequence becomes 290. So therefore, S of n is greater than 290 first when n equals 28. And that's how you'd end up with the 4 marks for that question.